Hello class. Today we're going to be talking about a conditional probability. We're going to move on from the traditional probability setting in which we've been doing it for the past 2 weeks. And we're going to add in just a little bit of a small twist to the probability questions that we're all used to. And so it's going to get a little bit more challenging from this point onwards, but you just have to remember how to deal with the what to do when I'm giving you this word. This word is what you're really looking for. And once we go over some several problems, we're going to be taking a quiz most likely by the end of this week. So on a weekly basis, I'll give you an assessment to make sure that you have a grade for those. Okay, so let's get started with the conditional probability here. Now, first of all, I would all like you guys to have the definition written for you guys somewhere, written somewhere in your notes. So the definition is that the probability of A like a little line, B, is equal to probability of A. I know that you're not used to this symbol, but this symbol simply means and. Remember when we talk about the Venn diagram, when there's a little bit of a gap, where there's a little bit of an overlap, that's the and portion of the probability over the probability of B. So when you say this, it's probability of A. We're talking about probability of A given situation B. So that's how we read. Probability A given B. This little line here, it indicates the word given. Okay, so we're going to go over what that means. Okay, so this formula I would like you guys to write down for you guys somewhere. Just like here when it says given two events A and B from a sample space S, the conditional probability of A given B, that's what we say, denoted by probability of A with a little line B, is defined by this. So that's the formula. So everybody please write this down. And then we'll continue on from where we left off. Note, probability A given B is a probability defined on a new sample space, B in this new sample space. This means included, if you want to know. But this really, the note is really not useful when we're doing the problems on the next slides. So let's take a look at this table. There's a lot of questions here that we're going to be dealing with. So use the table below to find each probability. So for the first quite several of these guys, like maybe about this much, they're all okay. We all should know how to do A through D. The only problem that we should be having, the new ones, should be E and F because of this given statements here and there. Can you guys pause the video? Try to solve for A through D, and then play it again once you have it. Okay, so probability that has less than a high school education. So first of all, when we're given this kind of question, we always first want to solve for the total here. We're talking about the entire employee, so we want to find the total number of employees here. So if I were to add up all of these numbers, so I gotta get my calculator out here, and then I'm just gonna simply type in 69 plus 1112, 112, 102 plus 13, so that's gonna give me 296. 36 plus 98 plus 193 plus 173, that's gonna give me 500 exactly. 2 plus 14 plus 143 plus 245, that's going to give you 404. Now, why do I have to find all the totals? You will see in the end, but I will advise you to first write down all the totals from each of the, not only the columns, but also the rows as well. So just people with just less than high school will be 69 plus 36 plus 2, which is 107. The next one, 1498 plus 1112, that's 224. 102 plus 193 plus 143, that's 438. With all these numbers combined, we're not adding all of these 6 numbers, we're just going to add this way or that way just once. So 296 plus 500 plus 404, well, that's going to give me 1200. Oh, I forgot the last row, right? 13 plus 173 plus 245, that's going to give me 431. And notice that if you were to add all those numbers, all 4 numbers that way, you should also get a 1200. So now I can go and do these questions. Employee that has less than a high school education. Well, less than a high school education would be these guys right here. So that's total of 107. That's that's why I wanted you to just add them up first, because it's really easy. It's eye-catching to have the numbers in front of you. So it's going to be 107, but then it's out of the probability of out of all the employees, which is 1,200. So that's what you're going to write down for the first question. Next is the probability of employee earns under $20,000. Well, earning under $20,000 are these guys in total, which is 296. And it's still out of the employee, so it's out of 1,200. Employee earns over 30,000 and has less than a high school education. So this is talking about the word and, right? So not only does the employee earns over 30,000, but they have also less than a high school education, which is just this 2, because they both have to coincide. So it's an and situation. So people that has over 30,000 and people who has less than a high school, the only people that overlap those two, there's only 2 of them that matches that description. So that's 2 out of 1,200. You can reduce it to 1 over 600. It doesn't matter, but it doesn't matter either way. I do prefer the reduced version on the quiz and test, and I'll make sure you specify that. But for now, I just want you to understand how to do these questions. Probability that our employee earns under 20,000 and has a college degree. Well, that's literally the far end corner from this answer, so that's 13 out of 1,200. Okay, so now all of these are done. These should be okay because you're just looking at the table and then you're just getting it out of the common thread here is that all of these denominators is out of 1,200. Because we're talking about an employee. We're talking about people that is going to be chosen from only those guys only. Just, well, the entire context, the entire sample space. This is the sample space, we call it. Or in this case, we call it the population. Because that's the entire number of people that has been surveyed, that's the total number of people. But starting in the conditional probability, your denominator is subject to change. Your denominator is no longer going to be 1,200. It's not always going to be, out of the employees, because here's how you want to read part E. Employee that earns over 30,000, given that the people has only a high school education. People who earns over 30,000. But the population, the sample space, the new sample space, is that the people only has high school education. So this second context here is super duper important in the sense that this will give you always your denominator number. Okay? You're choosing out of only people who has high school education. So high school education means these guys right here, 224. So notice how only out of these high school education people, how many of those guys earn $30,000 or over $30,000? Well, it's going to be 14. So you simply say 14 out of 224. Now, let's utilize. Okay, I'm going to move this up here. I know it's going to get super messy. I'm going to just delete that. Okay, now take a look at this question and then let's take the formula that we have been doing before. Probability of A given B is probability of A and B given probability of B. In this case, what is my A? What is my event A? Employee that earns over $30,000. Probability of B is the high school education. So we want to do this formula. The probability of A and B happening at the same time, well, that's 14. Because people with a high school degree and people who earns over $30,000, well, that's probability of A and B, just like how we have saw for part C. So that's probability, that's 14 out of 1,200 as if you were to get an employee, like choosing out of the number of employees, which is 1,200. Now, probability of just B is the high school education people, right? Well, the high school education people, what's your probability of choosing a high school education people? That's total number of people who've done the high school, which is 224. So I'm going to say 224 over 1,200. Now, when you do this, 14 out of 1,200 divided by, I know it kind of looks weird, but that's same thing as saying divided by 224 over 1,200. Keep, change, flip. So these two would cancel out, and then you have 14 over 224. Notice how we got the exact same answer right here. please you take this time and try doing part F for me. Pause the video and let me know when you have it. Okay, so employee that has less than a high school education and then earns over $30,000. Now it's pretty much the same context as E, but now it's been swapped. Now whether you did it using the formula or whether you did it by using what I just did here, I just take a look at the number of people that earns over 30,000, which is 404. I told you that these numbers will come in handy. And then employee that has a less than a high school education, well, that's 2, right? So given that it's over 30,000 people, how many of those people earn less than high school education? Oh, actually, wait a minute. It's not exactly the same because it says less than high school education, so it should be 2. So that should be the answer. Well, how do I utilize my formula to do the answer for me? Well, it's probability of A and B given that probability of B. What is probability of A and B? Both of them coinciding together, which is 2 out of 1,200 over people that earns over 30,000. Well, that's 404 over 1,200. Same thing. 1,200s will cancel each other out if you want to think of it that way, and you will get you the same answer as I've gotten before. 2 out of 404. Okay, so this was a beginning intro to probability, conditional probability to be specific. What I would like you to do is I would like you to solve these, 7 questions, number 2 and number 3, and there's multiple parts to it for homework, and just upload it on Google Classroom, and that'll be it for today. Thank you, and I hope stay safe, and I'll see you guys tomorrow.